Hello YouTube, Ron this side. So today's video is upon RBAC in Kubernetes. So RBAC stands for Role-Based Access Control. So RBAC is all about managing access to resources. It is not about identifying a specific user or authenticating them. It also helps lots of people and resources. It's difficult to manage or inventory of who can access what. So needed an automated system in place which can allow or deny access to a resource. So in short, RBAC in Kubernetes is a mechanism that regulates access to resources based on roles assigned to users or service account. It ensures that only authorized entities can perform specific actions on resources like we have pods, deployments, stateful sets, daemon sets, or secrets, and etc. etc. So this is a simple definition of RBAC in Kubernetes. So what is benefits of RBAC? So in this slide, you can see that it reduces admin load as RBAC can largely reduce manual redundant access provisioning. It can reduce cost by cutting manual efforts because using YAML manifest file, we can easily assign roles and other stuff without any manual efforts. We can enhance compliance as this is more of automation with defined rule set. Risk of breach is also avoided as human error avoided here. So this is RBAC sequence which Kubernetes implement in its cluster. So suppose we have a user, it starts authentication with Kubernetes cluster and Kubernetes cluster sends authorization token to establish connection and also try to uh, like uh, decide if the user is authorized and authentic so that the user can perform actions. If authentication and authorization both passes, then user can access resources on the Kubernetes cluster in which he or she is trying to access. After that, if we have implemented RBAC, then the RBAC policies will try to search or check permissions, like what all permissions has been assigned to this user on which he or she can perform actions. After checking the permissions, RBAC sends the permission decision, and after that, according to the decision, the user can access the application, the resources, or it it cannot be. Means resource access can be granted or can be denied. So this is a simple workflow like how Kubernetes implements RBAC. After this, RBAC uses for Kubernetes objects, which is role, ClusterRole, RoleBinding, and ClusterRoleBinding. Okay, so role is a set of permission that grants access to resources in a specific namespace. So you can see that it is namespace dependent. After this, we have ClusterRole. So ClusterRole grant access to resources across the entire cluster. So this is namespace dependent and namespace independent, sorry, and ClusterRole can grant access to any resources apart from the namespace. After this, we have role binding, which associates a set of users or groups with a role. You can simply understand role binding that we have a user and we have assigned role to the user. So in combining user plus role using role binding, we can perform this role binding action. After this, we have cluster role binding. So cluster role binding associates a set of user or group with a cluster role. So in role binding, we have to associate user with role, and in cluster role binding, we have to associate users or group with the cluster role we define. After this, we have user. So because user is the only one which is a necessary entity of RBAC as well. So user in Kubernetes represents an external identity that interacts with Kubernetes API managed by an external identity provider with permission control via roles and cluster roles. So user can we can associate user with the role as well as cluster role. And we have service account as well. So service account is a Kubernetes managed account used by applications running in pods to interact with Kubernetes API with permission control via roles and cluster role. So you must be confused like user and service account seems similar, but there is a unique difference between them, which is you can understand user as an external identity that interacts with Kubernetes API, but that is not the case with service account. So service account is not a physical user or external user. Okay, so these are the components which we will be using uh, in RBAC, and this is a diagram like how these resources are created, and in which part of the cluster they are created. So in the last slide, we are sure we are we came to know that role and role binding, these both are namespace dependent, so they must be reside inside a specific namespace. And cluster role and cluster role binding, they both are namespace independent, so they can reside in any part of the Kubernetes cluster, means they are not restricted to reside in a namespace. And in this picture, we have two roles and two role bindings, which is associated with the service account, and the service account is also associated with a cluster role and cluster role binding. And according to these implementation, the service account will try to access or create the pod resource. So in this video, I will be focusing on creating role binding, service account, and user. So in my next part, I will try to cover cluster role and cluster role binding with a demonstration. So this was the slideshow or presentation which I have created. I hope you all liked it. And if you think this is a positive initiative, then I will try to implement this thing in my future videos as well. Okay, so this was the theory part of RBAC. So now let's jump to the demonstration part as well. So for this, I have created a GitHub repository in which I have created the README file and some YAML manifest file. So we will try to understand each part when we will be starting with the demonstration. So step by step, we will use the step which I have mentioned inside this README file, and I will try to explain them as well. So let us start with the demonstration part. So this time also I am using Killer Coda Playground of Kubernetes version 1.30. So yeah, my cluster is up. Let's check the nodes. Okay, so nodes are ready. So let's start with the steps. So first, we are given with OpenSSL command to create private key. So private key we are creating here to create our user and to integrate the user inside our Kubernetes cluster. So let us copy this. You can also check the comments as well in this README. I have tried to explain each and every command I have written here so that in future or if you are playing along, then you can easily understand like which command means what. So it has created a private key. So I'm taking Tom as my user here. So this is the name of the user I'm creating. You can take anyone. After this, so now I am just like creating. So we are just using the private key, and after using this private key, we are creating a certificate sending request. So certificate sending request is an object which is required to create user inside our cluster. So this is the meaning of this command. I think we can close this. Okay. So after this, let's copy this. So we have created a certificate signing request file from the previous command. Now we are encoding or like encrypting this to base64. So this is the base64 code. Let us open a new tab because I will be needing that to um, paste in my one of the YAML manifest file. So here I'm using this csr.yaml manifest file to enter the base64 encoded secret which I just created. So let's open this. Okay, so in the request we just have to paste that encoded data. Let's remove this. Okay, it was in first tab. Let's copy this from the starting till here. Fine. Tab 2. Okay, so we have successfully saved it. Now from the README we just have to apply this file. So we have created certificate signing request. Now we have to manually approve this certificate because we don't have any such automated thing here. So we have approved the certificate as well. After this, we are just trying to decode uh, the our like certificate, and we are transferring the same to a new file which is tom.crt. After this, let us check. So now we are just setting up our kubeconfig file for the new user we are creating, and the new user is Tom. So why this step is required? Because kubeconfig is the only file which helps the external user or anyone in the cluster to connect with Kubernetes cluster. So kubeconfig file is a very important file, and we are just modifying it by appending our new user. I think I have not copied it correctly. So yeah, let us also check what is currently written inside our Kubernetes, kubeconfig file. So to access that file, you just have to write, let me just clear this, cat.kubeconfig. So here, this is the default configuration which is created by this playground, and inside this the important things are the cluster. So inside this we have one cluster which is using this certificate authority, and this is the server URL, and this is the name of the cluster, and inside this and after clusters we have context. So these are the context, and you can see the cluster is Kubernetes here as well, and the user is Kubernetes admin which is created by default. So this is the thing which we are creating and the user we are using Tom, and the name is of this context is also this, and currently as we have only one context, so current context is this context only, and this is mentioning the kind config, and this is the preferences which is blank currently, and this is the user section where we have given the name user as Kubernetes admin, and these are the certificates related to this user. So now as we are creating a new user, so this kubeconfig file should be modified with the user we are creating. So clear it, copy this command. So now the prompt has given us user toms is set. What happened? Okay. So now let us try to access kubeconfig again, and let us check if it has uh, added our user or not. Okay, so in the end, you can easily see that it has added our new user, which is Tom, and these are the certificate path which it has fetch from the terminal or from the directory. So the CRT file and the private key, it was uh, in the root directory. So this is, it has correctly taken the credentials. After this, let us check how many context currently we have. Clear this. So you can see that this is the only config, the context. So we have to create our context as well for the specific user we have added. So for this, let us attempt this. So now we have created context name as Tom context, and it should use user Tom. So now let us apply. Okay, now let us check if it has, if it is showing our context or not. So see, here you can see that it has added our context, and the user is Tom, and the namespace Tom is using is default here. And this is the sign, this asterisk sign resembles that currently we are using this context. If we have to change the context to our context, so we just have to write this command, which is kubectl config use context, and use context means Tom context here. So it is switched to our context. So yeah, so now the current context is our Tom context. So just for the meanwhile, let us again change our uh, context to this context, which is Kubernetes admin, because I have to apply some Kubernetes manifest file, which we cannot apply using the Tom. So this is the manifest file for role and role binding. So here you can see that the kind is role here. This is the API version for it. Namespace is default, as role is namespace dependent, so we have to mention the namespace. The name we are giving for this role is pod reader. API group is the core API group. Resources we want to access using this resource, this user is only pods here, and verbs or actions. So we want to apply these actions only. Apart from these actions, our user cannot do anything. And again, a new role, and it is also using the namespace default. The name is different here, and API group is core API group, same resources, but action here is only create. Okay, so now our role is done. Now we are starting with role binding. So role binding is a kind. API version of role binding is this. The name of our role binding is read hyphen pods, and namespace is default because role binding is also namespace dependent. So now this is the main part. So here what we are doing is we are adding our user and we are also adding a service account, and we are referring role. So using user plus service account plus role, we are binding all of them using role binding. So it means that our user Tom and our service account Tom-SA, which we will be creating just after this file, these two entities will use this role to take actions, or they can perform activities on this uh, Kubernetes cluster on the specific resources, which is pods. And we have another role binding 2. Its name is manage pods. Namespace is default, and here we are just binding our service account and the role. We are not using the user here. So yeah, these are our role as well as role binding in a singular manifest file. So let us create this nano role slash rolebind.yaml. Paste this. After this, we are creating a service account as well. So for the service account, it's a very simple YAML. We have to just mention the kind, the name of the service account we want to give, and the namespace we want it to be created. Nano sa.yaml. So we just have to apply this manifest file. Okay, certificate is unchanged because it was done earlier. Our role is created. Another role is created. Role binding is also created. Role binding 1 and role binding 2 is also created, and the service account as well. Okay. So now let us do some experimentation here, or verification, like what we have done till now is correctly configured or not. So for that, let us jump to our context, or switch to our context which we created, which is Tom context. Okay, so let us check if the verbs which we have mentioned for the user, are they correctly configured or not. So let us copy this command and paste this. So this command simply means that we are checking if uh, we have set user as Tom and the namespace is default. So can I get is the action which we mentioned inside the role. Get is the action and pods is the resources. So we are checking if this user which is running inside this namespace, means which is using this namespace, can it get those events, or like logs, means if it can access the pods with this action or not. Okay, yeah, sorry. I think for that we have, because this user does not have this verb. So yeah, sorry, I forgot. We have to check. I think we have to switch to this context now. Okay, my bad. So yeah, now run this command. So it has given output of yes. Okay, so now let us check for another action or the verb which we have mentioned. And now the action is watcher. You can let me open that in parallel so that you can also have a look. So we have checked for get. Now let us check for watch. So for the watch also it has prompted yes. After this, let us check for list. I just have to change watch to list. Now it is yes. Okay. So for these three verbs which we have mentioned in the role, for those, this user can access, or this user can perform actions. So now let us check for another verb which we have not mentioned inside this role. So now let us check for create. Yeah, so for this create, it has given no. So yeah, our role is correctly bind with the role binding and sorry, our role is correctly bind with the user and the service account. Fine. So this is how you can check for the user. Now let us check uh, for our service account, which is tom-sa. Let us copy this. So the same command here for the service account, but little modification as we are using the system, and inside this is the service account, and default here resembles namespace, and tom-sa is our service account name. So here we are checking that if this service account, which is tom-sa, can create pods or not for this default namespace. So yeah, it is saying that yeah, it can create pods. And let us check for our another verb which we have not mentioned for this role, which is binded to our tom-sa service account. So we are checking for delete if this service account can delete pods or not. So it should give output of no. So yeah, it is working as desired. Okay, so let us try to just create a pod for our user if we are able to create the pod or not. So for that we have to switch to our context, which is tom context. We have successfully switched to our context. So let's just write simple command to create a pod for our Nginx app. So kubectl run Nginx. Let us give this as Nginx hyphen pod hyphen image of Nginx. So yeah, here you can see that we have got an error from server, which is error from server forbidden. Pods is forbidden. User Tom cannot create resources pods in API group in the namespace default. So our policy is correctly working, which we have attached for our user. So our user can only list the pods, get the pods, and watch the pods as well. So for that, let us try to create pods using the context, which was by default and which has all the admin access. So we have switched to this context, and now try to run this command, and now the pod should be created. Okay, so kubectl get pods. Yeah, so pod is in container creating status here. Okay, so it is running. So now let us try to jump to our context and now check if we can get pods or not. Tom context, now kubectl get pods. Okay, so yeah, this user can get the pods, and let's try to do watch. Okay, so yeah, my user can also watch the pods. So this is a simple video like how you can implement RBAC. So it is a simple demonstration like how you can create user and how to integrate the user in your kubeconfig file so that user has authority and authenticity to access resources uh, inside your Kubernetes cluster. And in the same video, we have created service account, and we have bind our service account and user with the role which we created using role bindings. So I hope I was able to explain you like how we can implement RBAC in our Kubernetes cluster. and I will try to create a part 2 video of this of the same context, in which we will be creating cluster role and cluster role binding. So yeah, thank you for your time, and have a nice day.